Okay, a few people have asked me how you can run a 220 volt water heater on 110 volts. And so this is kind of a quick overview of how that was done. So my energy supplier actually had this contraption on the top. It's basically a time device, which basically switches off the heating here at times where, there's a spike in, energy demand. So to offset the load on the grid, they turn this thing off. And of course, the service has been discontinued now for a while. The energy company that I go through doesn't do this anymore. And so what we've been able to do, there's a couple of connectors on here. You'll see a black and red, and there were two spade connectors which are here. And if you follow these wires down, they were basically bonded to the electricity that's coming in, or the main electricity wire that's coming in. And so what I've done is I've made some spade connections which go in here, and then I have this regular black cord. This black cord that comes down, and you can see just about maybe that this is plugged into a regular power cord. This thing's energized at the moment, as you can see, but if we were to follow this cable all the way to the power station, and excuse my untidiness, but we have a wire that runs all the way through behind these freezers, and it plugs into a single AC200L. And so this is the extension cord that comes in here. And what I've got here, this is like an RV connector. This is a 35 amp to a standard 110 volt outlet. The only reason why I put this in here was I didn't want to sacrifice or damage any of these connections by running this at close to maximum power. And this has been running for a little while, but you'll notice that the power draw on this thing at 120 volts is 1,360 watts. It's not something I really like to run for an extended period of time, but it's been running this way for more than a month already. So let me get my thermometer and we can see how hot this thing is running. Let's start with this end just to see how hot things are getting. And I actually recommend, if you're serious about doing any solar work and you want to reduce the risk of fire, you could probably get one of these kind of infrared thermometers. And so this allows me to see how hot things are. And so you can see that this connection is probably around 120 watts, 120 degrees Fahrenheit. So that's a little bit on the toasty side. However, it's been running this way for a while. The hottest component actually by far in this particular setup is where this thing actually connects to the plug itself. And so I've actually seen the temperature of this thing go up to about 130, 140 degrees. So anyway, to mitigate against this, my plan is to buy an extension cord that's actually rated at least 20 amps, a good quality one. And instead of having the plug here or the socket on this end, just to cut the end off, re-terminate the wire with these blade connections and then plug directly into this thing. Now don't forget, if you are adapting this thing, it's absolutely critical that you isolate this thing from grid power. So you can see there's a disconnect box above here. The fuse in this place is being removed. It's here, and I'd probably recommend just putting it out of the way so no one is ever able to accidentally plug this thing in. Also, as a precautionary measure, I've also disconnected this from the our circuit breaker as well. So there is no way that this thing is ever going to be energized from the grid. But of course, the changes are reversible. So when we move out of this house, then we can return everything here back to normal again. Let's go and look at the temperature at the power station just to see how we're doing there. So here's the power station end of things, and I can see visually on here that some things are getting toasty. So we're talking about 90 degrees, 94 degrees Fahrenheit. And as we travel up the cable, it's back down to about 70. And then from there on, everything is fine. Now that heat spot I'm sort of focusing on at the moment is actually the exhaust of the power station anyway. This thing is working well within its limit. It's designed for up to 2,400 watts, and we've got another 1,000 watts to go. So this thing is going to be able to run, you know, for an extended period of time. I've taken a shower. My daughter's having a shower right now, so this will probably run for an extended period of time, because when this thing is running at less than 1,400 watts, it's going to take a lot longer to heat up the water fully than if it was running 220 volts, but it's not going to be as aggressive on this power station, and so I'm not really too concerned. As you can see, a couple of other bits as part of my setup here. I've got another AC200L down there. I've got a couple of eco-worthy rack mount batteries which are all chained together. We got some B300s, B300Ks, and then basically you know, I think between each and every battery that's in here, we're about 30 or so kilowatts in here, and so we're easily going to have more than enough power to run through tomorrow. And I'm looking at the other power station down below here, and that's running also just over 1,000 watts. That's running most of the house, and it's actually running a heater in the bathroom. So we're actually drawing a total of 2,300 watts in its entirety for running this house at the moment. Okay, so here's a little bit about the numbers. We're really looking mostly at the power consumption of the water heater, since that's mostly our focus. There are two lines that you're going to see here primarily. You're going to see green, which is basically showing the PV input into this generator. And you're also going to see the AC outlet, which is this yellowy orange color as well. The biggest spike that you see here is nearly 2 kilowatts. And that is where I was not only running the dehumidifier during the nighttime, but also I was also leaving the water heater to its own devices. And so some of the spikes you see here is just normal cycling on and off as water heaters do, even if you're not actually actively using hot water. You know, once the thermostat decides that the water is cold enough, then it'll energize the heater, and then it comes on. Go back a couple of days here, you can see kind of some of the usage in the system. We had some good usage on our water yesterday. We had kind of an unusual spike on the system, which actually got close to 3 kilowatts. Go to the previous day, we had a day prior where we made very, very little power, and so we just transferred our water heater to grid power. We did that. You see the day before that the battery level didn't really exceed 25%, so on our PV input was very, very low on this particular generator. And so at lunchtime I transitioned it to grid power. Now the PV graph in here isn't really that useful. It gives you an indication as to whether it was a good solar day or whether it was a bad solar day, as what you're seeing here. But this generator actually is actually getting charge input from its neighboring AC200L, which is co-joined. They share batteries, and also there are 3 additional solar generators that provide power into the battery system in this thing. So the graph in green here is not able to see all of that other power that goes into this. Instead, the only indicator you might see is that the battery graph is kind of an indicator of what the battery percentage is of the system as a whole, because the numbers, they drift a little bit of the charge percentages, but they're not wildly out. Okay, we'll have a look at another day, and then we'll look at some monthly numbers, so you can see what the monthly kilowatt usage pattern is on this thing. So 3:20 in the morning, thermostat calls for the water heat to come on while we're asleep. It comes on, it's probably on maybe half hour, no more than an hour, and then it shuts itself off, and then it's good then for 3 or 4 hours, and then it decides to come on again. Now those 3 spikes that you see between 8:20 and 11:40 is just usage patterns, hand washing, mostly hand washing. I don't think there's much else going on. And then the evening hours then from almost 17:30 through 22:30, that's typical, showers, maybe the dishwasher ran, and all that kind of stuff. Now if we look at energy, now let's have a look here. Let's scroll down, and on the 14th you can see that we use 9.42 kilowatts. If I go to month, this is March, let's go to the current month. For 14 days in, we've used 105 kilowatts. Now, I don't think that's kind of a true number, and I'll explain in just a second. Let's go to April. So April, we had a pretty good month. We used 244 kilowatts, 245 kilowatts. But in here, there are probably some poor solar days. Now, I can tell you, just based on my own experience, as an average, we need 10 kilowatts per day on average for all of our hot water needs. So that means that of the 30 days that we had for the month of April, then we're showing 244 kilowatts here. We probably transitioned to grid power because we didn't want to run our batteries too low. We do want to use more solar power for this, so what we may end up doing is that we might end up adding some more batteries to our stack so that we can be more reliant on solar rather than doing this switching over. So anyway, I'm hoping that you seeing some of these numbers is helpful for you to determine whether running your system from solar power is going to work for you. Oh, the other thing I should mention is that we're a family of 4. So if you're 4 or less, this solution might work for you. If you're more than a family of 4, or you have to shower absolutely every day, then this might not make enough power for you. So anyway, I hope that helps you.